Hi everyone, I welcome all of you in this lecture. So in this lecture we will discuss a new point of a linear algebra. So that point is range of t. So firstly we will see its a definition and then we will discuss its a definition one by one. Okay. So let t from V to U be a linear transformation, that is here V represents my domain and U represents codomain, and there is a transformation in between V and U. Be a linear transformation. So as we have already discussed what is a linear transformation in previous lectures. So then range of t is defined as, that is either t of v is equal to this or t of v is equal to this. That means t of v is equal to t of all collection of my domain such that small v belongs to capital V. Similarly, this can also be written as like this, that is t of v is equal to collection of all my domain, that is u belongs to U, such that this u will give us value, that is t of v, that means all the images of my domain, that is t of v, where small v belongs to my capital V. Okay, so these are my definition and we will discuss what is this actually. And similarly, range of t is denoted by this letter, that is r of t. Okay, so this is our definition. Now main question is, what is its meaning? Then we will check its meaning by graphical method. So for that purpose we will consider one domain, that is a V, and codomain as a U, and there will be a transformation T in between them. So for that purpose, this is my domain, this is my codomain. So domain as a V and codomain as a U. Okay, so whatever we will take a transformation in between them, what is its actually meaning? That means whenever we take any value from domain and any transformation when we apply on my domain, then its image will be here, that is codomain will give us its image value. Okay, so here we have a transformation as a t, and when we consider V, that is a domain, and domain contains small v element, that is a small v, and when we apply t on this transformation, then its image will give us value here somewhere, anything here, that is a t of v. Okay, similarly if I choose another element, that is a v1, then when we apply this t on this v1, then its image will give us answer, that is a t of v1. Similarly, up to so on, if I choose V2, then we will have this image as a T of V2 in this capital U. Similarly, up to so on, if I choose Vn as a nth element which are from domain, and when we apply transformation on this domain, then its image will give us value, that is will give us image, that is a T of Vn. Okay, so that what is this? Okay, so for that purpose we will consider another diagram which is actually same. So this is my domain, again this is my codomain, and this is, there is a transformation in between them. Okay, so when we choose any value from domain, then its corresponding images are we are collecting in codomain. So if I choose this element, then its image will give us this value, means this is the range. Okay, so collection of all this domain, when we take its a transformation, then its image will be here, that is in codomain, that is this is our image set. Okay, so image set where it belongs to our codomain, that is each and every element of a domain will give us image in our codomain. So of course by definition we can clearly say that is image set. What is the image set? This is nothing but our T of V. Okay, T of V means if we choose here V1, then we will have a T of V1 as an image. If we have here V2, then its image will give us answer T of V2. So in general, if I take V here, then it's a transformed value, that is image value, that will is a T of V. So this is set of a image set, and if we call this set as a T of V, then now observe our definition, that is range of T means collection of all the images, that is collection of all these images, and check this small v belongs to of course capital V, where it is from, that is this is a domain, that is collection of all my domain, and when we take its images, then this is the T of V, then T of V is the collection of my all the range of T, and this T of V where it comes from, of course from domain, because V is from our domain. So this is the definition of range of T. Again we can see this is a T of V, that is a range of T, this is a collection of all the images, and this V is from, of course, domain, and this can also be written as like this, that is a T of V, and this is a U belongs to U, that means this set is a nothing but a small u, and this small u belongs to our codomain, that is a capital U, such that U is nothing but a collection of all the images, that is a T of V, and this V also from belongs to domain V. Okay, so this is our definition of range of T, and from now we can call this T of V as a R of T, and this is nothing but a range of T. Okay, from this diagram, as we have already observed, all the image sets are present in our codomain, then we can clearly say that is all the images set are denoted by T of V. So T of V are a subspace of which set? Of course, codomain V. This is an important case which we have obtained from this diagram. So from now, whenever we take a range of T, then it is a subspace of our codomain, and this is possible with the help of this diagram.